So here we are in the new lesson for today, and it says this, but I know better. Mostly for today, we are doing a review for the test, and they're saying we should talk about identifying transformations from exponential functions. What does that mean? That means if I give you this 2 to the x, but then I do this to it, plus 3 minus 4 on the outside, and a negative here, could you tell me the 3 things that just happened? Christian, can you name one of the things that happened? Hint, there's a left move, and there's a down move, and there's a reflect. It's reflected, but which way? Careful, it's on the outside. Vertical reflect. How do you know it's vertical? Because it's high vo. This stuff is called the high part, horizontal on inside. That's the vo part, vertical on outside. So as a vertical reflect, Veda, another thing that happened. Down 4, you are correct. And last but not least, Spencer, what's this part here mean? Hint, it's horizontal, which is like left and right. Left 3 is correct. All right, so that's one of the things they ask for today. That's pretty easy. It's the other thing they want us to do. I can graph reflections. So basically, that's the hardest kind to graph, is if there's a reflect. All right, everybody get to this page, second page. Is this growth or decay? And it should be like a 1 second look and you're done. Graham, do you know?
It's decay.
It's decay. Now, here's the harder part. What percent decay is it? Everybody think this through. That's clearly less than 1. And the way I would think in my head is like this. It's like you did 1 minus something, and that will tell you the rate. The 4 is the starting amount. This number right here, what did you subtract from 1? How many of you were thinking 0.2? Raise your hand if you thought of 0.2. You are correct. 20%. 20% decay. And the rate of change, 20%. And it's decay. And what's the 4? What did I say it was? Start. It's a start value. If you have 4 llamas and you're going to slowly have their population of llamas go away. I've got 5 cats in my house right now. Not kidding. It's kind of crazy. My daughter raises cats. She's on vacation. We're watching them for her. Those 5 cats, assume I didn't have any baby cats, because they're all females, which they are, then sadly, but true, over time, eventually, one of those cats is going to pass away, and then another one would, and eventually all the cats will eventually die. I will hopefully outlive these cats. Because cats only live like 10, 15 years maybe, sometimes 20. Right? So if you just have a decay rate, that makes sense if the cats are all females. If I had a male cat in there, then all of a sudden you might get some growth. In fact, you get quite a bit of growth. All right, moving on to this one. Everybody get on this slide. It is slide 3. It is asking you for this A is the y-intercept. Oh, no. It's the starting value, which is also the y-intercept. Interesting. But the main thing I've told you is that's the start value. It's also the y-intercept. Because if x is 0, look what happens. If x is 0, do you get that whole thing will go away if x is 0? I mean, it'll turn into a 1, but then that means it's the y-intercept. Never even talked about that, but it's true. If x is 0, put a 0 right there in your head, then that whole black box would turn into a 1. So the start value is also the y-intercept. All right, B is considered the base, and it'll tell you whether it's growth or decay. And whatever's bigger than 1 or less than 1, that's what it's growing or decaying by. Whatever it's bigger or less than 1 is the growth or decay rate. It's also called the common ratio. We haven't used that word very much. Don't worry about it. Okay, this one's growth. this one's decay. Those make sense to you? What if I put a negative in front of this growth? Then the whole thing flips upside down like that. All right. And we already talked about how if the base is bigger than 1, you get growth. If the base is between 0 and 1, which basically means less than 1, then you got decay. Good. This is the hardest part, ladies and gentlemen. Not is it growth or decay. I mean, I could seriously get a third grader to tell me whether it's bigger than 1 or less than 1, right? That's pretty easy. But how much growth or how much decay is it? Because like, duh, that's decay because the base is less than 1. But how much decay or growth is it? So here, let me teach you how to do this. Remember that you'd have a calculator, and I'll be like your calculator. You could take 2 divided by 5, and it would be 0.4. And that gets it a little better. But then the way I would always do it in my head is I would always make this into a 1 plus or a 1 minus something. I want you to process that for a minute. If it's 0.4, wouldn't that have to be 1 minus something? 1 minus what? 0.6. Then that's your what rate?
Growth?
Nope, it's not growth. Remember how this is less than 1?
Okay.
That's your decay rate. Do you get how this turned into a decimal, which turns into, this is where you rewrite it as 1 minus something. That's the hardest thing to figure out. Do you feel like you could do that? So then here, you might be like, well, it's growth, Mr. Server, and it's 400% growth. No, you're wrong. It's not 0.4% growth. No, it is not 0.04. Now just don't keep on throwing decimals out. It's not right. So let me show you what you should do. You should rewrite this as a 1. Would you agree I have to do 1 plus something to get 4? So then it's 1 plus 3. So now would you like to decide what growth rate it is? It's not 400%. It's 300%. Because remember, it's the part that's bigger than 1. That's the growth rate. And I hope you know that the decimal in 3 would be there. So you move the decimal 2 spots, 300% growth. I warned you, this is the toughest part. Easy mode is this growth or decay? Well, duh, it's growth. But can you tell me, don't say it out loud, think it. Don't say it out loud. What would go in here, and that'll tell you the growth rate, and it is not 300%. I'm going to pause for a second. Try to figure out what goes here, and I'll see who gets it and who doesn't. Excellent. So if this is 1 plus 2, clearly that's how you get 3. With a 1 plus, that's telling me it's growth. And what percent growth is it? Liliana, what did you get? Not 0.2, that'd be 20% growth. It's big growth. Timesing by 3, would you agree that makes it quite a bit bigger? It's not 20% growth. Think it through, you can do this. 200% growth. All you got to do is move the decimal 2 spots. And where is the decimal on a 2? It's right there. So if you move it 2 in the wrong direction, I'd forgive you. But I hope you would look at this and go, that can't be 0.02. Like, 2 shouldn't be 0.02. 2 changes into 200% growth. That's what growth it was. How many of you would have got that right? Okay. And then this one, growth or decay? Decay. Would you agree that this is 1 minus something? 1 minus what? 1 minus 2/3 would give you 1/3, right? So then that, if you used a calculator, it'd be 0.66666. What do you think the decay rate is? How far do we move the decimal? 2 spots. 66% growth. Or decay, sorry. 66% decay. All right, that's the hardest stuff. All right, I am gonna eventually get to those 4 like test questions, but these are all good lead ups to that. Horizontal asymptote. Here's the most common mistake answer. Y equals 3, because you said it's the thing on the outside. Wrong. This one is y equals 2, though. What's that first one's asymptote?
X equals.
Nope, it's y equals. They're always y equals asymptotes for these, because they're horizontal. Remember, that's horizontal. You always start with a y. Y equals 0 is correct, because there's nothing out here. Y equals 0 asymptote for that one. Y equals a 2 for that one, because the asymptote moved up 2. And hopefully, if you catch on to patterns well, you'll see it's the outside one. Y equals -3. Make sense? The whole thing moved down 3, so that makes sense that the asymptote would be down here at -3. Okay. The MHS underwater hockey team, of course you don't really have one of those, is started with 7 members. Ooh, I know where to put that. Do you know where to put that? Right there in the front. It has averaged a growth of 40%. Ooh, I know how to do that. Do you know how to do that? Spencer, what do you think I should put in here if I want to get 40% growth? Hint 1.
1 plus 0.4.
Correct, sir. That's 40% growth. Victoria, what do I need up here? Usually we have an X, but did they tell me anything about the problem that makes me think I should put something besides X up here? Ah, it's the years. Now, do you guys remember the kind that have an E in it? We will tell you that the problem is called a continuous problem if it's got an E in it. And the formula for that will be P times E to the R times T. We will give you that formula, and you only use it when it's continuous compounding. The word continuous will be there. Otherwise, we'll tell you, you got to use this formula. But if we tell you it's continuous, you got to go, oh yeah, that's the one with the E in it. Continuous kind have the E in it. All right. Point 2, does that feel like decay or growth? Decay. Can you do it in your head? What percent decay? Make it into a 1 minus something if it's really decay. 1 minus what? Come on, you can do this. 1 minus what would make 0.2?
20%.
Nope. That is not 20% decay.
1 minus
1 minus 0.8, and the 0.8, see 1 minus 0.8 is 0.2. And then this is your decay rate. 8% decay. Wrong. What is it? 0.8. You got to move the decimal 2 spots. What percent decay is that? 80% decay. At a minimum, can you agree that we always move the decimal 2 spots? I get how it can be confusing if it's left or right, but you gotta move the decimal 2 spots. I can't just mark it right if you go the wrong direction, but at least I'll understand. Well, at least they knew they should move the decimal 2 spots, but your answer could not be ever where if you move the decimal other than 2 spots, you can't be right. Okay, so back over to this one. This looks like to me like decay because it's 1 minus something. Can you figure out what? Heck, you could keep playing with the calculator until you finally figure it out. 1 minus 0.7? No, that didn't work. 1 minus what? Got it, Eli?
0.07.
Yes. And now I'd ask, what's the percent decay? 7% decay. Sometimes it helps to get a normal one like this and go, oh yeah, 0.07, that's 7%. You know that one, don't you? And then if you get a weird one like 0.9, and you're like, what the heck is that? Well, look back at this one and go, oh yeah, I moved the decimal over 2 spots this way. And that'll remind you, oh, I guess 0.9 is 90%. Okay? So if you get confused on a weird one, just go back to a normal one. There's another normal one. 1 plus or minus something. Veda, is this a 1 plus or a 1 minus? Point what? I think it's 18. Can anybody verify 18? Okay. How could I do that with a calculator? Try it. You go 1 minus 0.18 and it gives you 0.82. So then, is this growth or decay? Decay because it's going down. Decay of what percent? 18%. All right. Now, what would this is my screen, the side where I get to like pick anything that I want to talk about that I think might be like the hardest stuff on the test. And I think that it will be either the application problems where you like say, we've got a car and it's depreciating in value, okay? Because that's a real good, real life thing, and it's an application problem, which was like the last thing we did, so it's kind of hard. Or plain old-fashioned graphing. So let's do, since we've done so much practice already, let's just do one graphing and then one application question. All right, so here's a graphing. Y equals negative 4 parentheses, 2 parentheses, to the x. I'd say that's about as hard as it needs to be. Now, is there anything on the outside? Then you should be able to tell me the asymptote that's there. Y equals 0. Would you agree there's a y equals 0 asymptote? Okay, so everybody start with the graph and put a y equals 0 asymptote. And then this, if I could only pick one thing you'd be good at for graphing, it would be finding dots. Because if you can find 3 dots, you'll be able to go, oh, that's where the graph is. It goes through those 3 dots. Mr. Washington, give me 3 logical things to put in this.
-1, 0, and 1.
Perfect. August, you get the lucky job of putting in -1. When I put in 2 to the -1, do you remember what that does? Correct, so it makes it 1/2. Can you times that by -4 in your head? Half of 4, and then make it negative. -2. So this was 1/2, and this was a -4. So I got 4 times a half is 2, and then it's negative, so -2. -1 comma -2 is a point. Victoria, put in 0 for us, and tell me, walk me through what happens.
Times it by, or 2 is that, that's 1.
Wait, that's 1. Very good. That part's 1. And then what?
And times it by -4.
So the answer is?
-4.
You are correct. 0 comma -4. Vivian, you get to put in 1. We're putting it right here. What is 2 to the 1?
2.
Times -4.
-8.
Now everybody graph those 3 points. Now I have these 3 dots. Actually, it should go a little lower if I'm going to stay consistent on like where. So 1 comma -8 would be like right about here. And I'm going to draw my line through them. Asymptotic behavior means you get closer and closer, but you never touch the asymptote. And there you go. That is a typical hard graphing question. How many of you feel well prepared for that kind? You're going to be good at that kind. Okay, good. Then last we'll do the 2 different ways we could do the word problem. One is with this formula, where the amount is the starting times the 1 plus the rate, all to the x. And the other is this formula, PERT. P times E to the R times T. All right, so it's like a multiple choice. Which one should I use? Okay, so here's the question. You got $1,000. Your rate is 4%. Your time is 3 years. How do you know which one to use? Did I ever say the word continuously? No. Then you use this one, which is easier. It doesn't have to deal with E. If I had said this compounds continuously, then you would use this one. My advice right this second is try it both ways. You'll get a slightly different answer. I think continuously will be a little bit bigger answer. Okay, so how do we do this then? Well, you put the 1,000 in as the starting amount, or it's the principal. E, you should know where that is on a calculator, and I'm going to hand out calculators in a second. The rate, either way, the rate is 4, but oh, please don't put in 4. What do you put in? For a rate of 4%, what do you put? That has got to be the weakest thing that you guys have. 4% is 0.04. You've got to get this through your head of how that works. So you should have put a 0.04 here or here. And duh, time is 3. So you just put a 3 in. Don't overthink that. Try it both ways, and I'm going to walk around. And if you get stuck with your calculator, I'll happily help you. I'm going to pause while I hand out calculators. All right, everybody's got a calculator now. I'm telling you, if you do it both ways, they'll be close, but they will be different. If you're having trouble putting in the E, my advice here again was figure out the power first. Use your calculator to get that. And then do the E to the power. And the last thing you do is times by 1,000. I think the order of operation will mess you up otherwise. I do the 0.04 times the 3, and then do E to that, and then times 1,000. Okay, so get your 2 answers to this question and be prepared to talk to me about it. I'll pause while you try those. I got 1,124.87 if I round it. Can anybody verify that number? You got the same exact thing. 1,124.87. Yes?
0.86.
Okay, but, oh, you know what? You're right. I screwed up the rounding. I thought it was rounding up, but it is not.
No, I didn't round at all.
I hear you. I rounded and I shouldn't have. So what I'm saying is I screwed up the rounding. So you are correct. 1,124.86. Raise your hand if you had that one right on the top one. Okay, good. For the bottom one, my advice was to do the power first. So that's 0.04 times the 3, and then put E to that power. So E to the power of 0.12. And then times it by 1,000. And that's 1,127.50 if I round it. You might be like, that's pretty much the same thing, Mr. Server. It's only off by 3. It is. But if this was in millions, do you get being off by 3 million would be a lot. So if your bank offered to compound continuously, you'd get this amount. If your bank was compounding it daily, you get that amount. Slightly different. Okay? So compounding continuously is a little better. It gives you a tiny bit more interest, you might say. All right, cool. So that's a pretty good review for tomorrow. And I'd like you to pull out that worksheet that I told you could start on yesterday. It could be on your iPad, or if you happen to be here today, I'm going to give you a paper version. So I'm going to pause for a second while I hand those out.